So we're continuing with section 15.4, segment relationships. This time we're talking about when you have secants and tangents intersecting outside the circle. There's really three cases the book analyzes, but I'm not going to really focus on case one because we've already discussed case one. Whenever you have two tangent segments coming from the same point outside the circle, these two tangent segments are congruent. So I'm not even going to worry about that one because we already know how the two tangent segments are related. We don't know how these segments are related in terms of secants or a secant with a tangent. So the way we're going to be doing this, I'm only going to derive the two secants case. The secant and tangent case, in my opinion, is just a special version of the two secants. So I'm going to show you the two secants derivation. So for this one, what I'm going to do is I am going to draw in again. I used similar triangles before when I was using two chords. I'm doing similar triangles as well. The way I'm doing this though is I'm going to draw in a chord here. I'm going to sketch in another chord here. Okay. Now here in this case, we have a lot of triangles. Now, some of you may try to use these two little ones, but I'm actually not going to use those. I'm going to use these big overlapping ones. So here's this big one in brown. See that big brown one? Okay. And then let's look at this one here in red. So the brown and the red triangles, those are the ones that I'm going to focus on. Okay, so first things first, if you look at that brown and red triangle, they both share this angle. Both triangles share that angle, okay? Next, if you look at the brown angle inside the circle, that's an inscribed angle of this circle. And the red angle is also an inscribed angle in the circle. Both of them intercept this yellow arc. So because they both intercept that yellow arc, they're going to be half of the yellow arc's measure. So they're going to be the same measure because you're taking half of the same number. So just so we're clear, let me try to draw this separately. You know that I like to separate triangles when they overlap. Okay. You have this big triangle here in brown. You have one tick there and two ticks there. And then you have this other triangle here in red. And you have two ticks there and one tick there. So those two triangles are similar by angle, angle again. The triangles are similar by angle, angle. So because they're similar, that means that their sides would be proportional. Now I know that I can focus on any sides, but I'm going to focus on certain sides specifically, okay? So I'm going to call in the brown triangle, I'm going to call this side A, okay? And its counterpart in the red triangle, I'm going to call it B. And then in the brown triangle again, by the way, let me draw it in the original picture. This whole thing would be A, and this whole thing would be B, okay? Then in the brown triangle, I'm going to focus on this part here, which would be, I'm going to call it X, and that would be right here. And then its counterpart in the red triangle would be Y, which would be right here. I know there's other things I could have done, but I'm leading up to something. Okay, and again, remember that I told you I don't like when they're not drawn in the same way because it gets misleading, gets confusing. So I'm going to redraw one of them. It doesn't really matter which one I redraw. Let's resketch the red one. So if I resketch the red one, doesn't have to be perfect, just more or less. Here's the two arcs, here's the one arc, and then the side connecting the two tick angle and the one tick angle is B, and then this side over here adjacent to the two tick angle is Y. Let me make that in white so you can see that a little better. Okay, so you don't look at this one anymore if that's confusing you. Just look at the two top ones only. So remember, if two triangles are similar, that means that their sides are proportional. So I'm going to look at these two triangles and I'm going to try to make a proportion. I am going to make a proportion. So I'm going to say there's others that I can do, but I'm going to say A over X equals B over Y. And if I cross multiply, I would have A times Y equals B times X. And that's basically what the relationship is. Now, let's analyze what A and Y and B and X are. A is the whole secant on top, and Y is its exterior part, the part outside the circle. B is the whole secant on the bottom, and X is its exterior part. So writing that out in words, which is the way I prefer that we do it, so we don't get hooked on these variables and then freak out whenever we don't see these exact variables, okay? So I'm gonna type this out, and then I'm gonna make like a little song out of it, which you're gonna laugh, that's okay. So for two secants, the way we say it is the product of one secant segment and its exterior portion is equal to the product of the other secant segments and its exterior portion. The way that I would always tell my kids to remember is the whole thing times the outside piece equals the whole thing times the outside piece. I know it seems silly. If we were in class, I'd have you guys chant it like 4 times. But since we're not in class, I'm just going to say it 1 time. But the whole thing times the outside piece equals the whole thing times the outside piece. The whole thing times the outside piece equals the whole thing times the outside piece. Okay? The whole thing times the outside piece equals the whole thing times the outside piece. Hopefully you chanted it along with me. Probably not, because I know you guys, but hey, wishful thinking. Okay, so let's do some examples. Remember what I said, it's the whole thing times the outside piece equals the whole thing times the outside piece. Okay, that's what we're gonna do. So I'm gonna do some examples with you. I'm gonna write this down to remind you also, okay? It's the, oh, that's too light for me. Okay, let's do the whole thing times the outside piece equals the whole thing times the outside piece. Okay, so for the first one, what is that whole thing? What is 11 plus 7? The whole thing is 18. Okay, just like you added these 2 pieces to get 18, you would need to add these 2 pieces to get that sum.